Hello everyone, my name is Barış Akıncı and this is my Physics 2212 Lab 4 Magnetic Field presentations and slides. So first of all, our introduction. In this lab, me and my group mapped the magnetic field of a bar magnet. We measured the X component of a magnetic field at several distances, estimated the magnet's dipole moment, and compared the data to a dipole field model computed in GlowScript. So with the computational model, we use GlowScript. For the system, we use bar magnet, phone, magnometer with a meter stick, and surroundings, Earth's field, and the rest of the environment. So fundamental principles. We use Faraday's law, Biot-Savart law to find magnetic field, and magnetic flux formula. For the procedure, orientation and zeroing, we align the meter stick roughly east and west to reduce Earth's magnetic field. And we hold the phone so its axis points along the stick, record the background field for the later subtraction. And on axis, for each R, we hold the phone at the tick mark, and log bx for 3 trials. And then for the 45 degree measurements, we measured the perpendicular from the axis. We placed phone to the perpendicular spot and record XYZ magnetic fields separately. And for the processing, we just record the values and put them into the spreadsheet. For our measurements, these are our measurements: the distance, average magnetic field, absolute average magnetic field, and the natural log of R, which is distance, and natural log of magnetic field. And for the magnet properties, we measured it. It was 0.025 kilograms, and magnetic dipole moment was 4.6 amperes per meter square. And for the experimental data, number of trials, we did 5 trials, and the average time was 0.76 seconds, and time in free fall was 0.43 seconds. To our coding part. This is my GlowScript code. In the left, I am calculating the magnetic field of dipole, taking the R, magnitude of R hat, and then finally using the Biot and Savart law to find the magnetic field. And on the right, that's where I'm creating the arrows and visualize how the magnetic field of magnet is representing. And the goal was visualize the bar magnet as a magnetic dipole and compare the data. And we use the Biot-Savart formula again, yeah. And for when I run my code, this was the result. This was the picture of our experiment. The orange arrows is on-axis arrows, which are more stronger, and while the cyan perpendicular arrows, which is a little bit less stronger, let's say weaker, and the magneta arrow marks the model field at the D perpendicular when D perpendicular was 0.2 meters away. And the what if questions. What if we had an aligned magnetic to the north? With the stick at the angle Earth's field, the magnometer's X reading would include constant Earth component and a reduced magnet signal. So it will not be like calibrated fully. And then the other what if question was 2 identical magnets were stacked end to end. If they aligned north to south and south to north, the effective dipole moment doubles. So every measured field is roughly 2 times larger than the natural log slope stays the same. If they're opposite, for example north to south and south to north, the far field larger cancels, giving much smaller readings and a pattern that no longer look like a simple dipole. and potential errors, and conclusion finally. Alignment, stick, not exactly, E, east, west, or phone X tilted lib maybe. Sensor calibration, a phone magnometer could be biased or like scale errors, and geometry and distance, marking R inaccurately. And lastly, thank you for the listening.